Welcome back to Python. Today we're going to be talking about network security and web security. Alright, so before we get started, I'll apologize for any background noise you may hear today. It's raining where I'm at, so we've got a little bit of background noise, but we should be okay. So today we're talking about network security and web security. Network security is basically the process of taking your sequence of computers, or all the computers and databases that you have linked together to create an application or a website, and trying to protect them from unauthorized access, modification, or destruction. And so this is basically a way of taking your infrastructure that makes up your data and ensuring that your data can be transmitted securely and confidentially, and preventing anyone that you don't want to have access getting access to your website. Now, web security, on the other hand, is slightly different. Web security is about protecting your websites and your web applications from attack. So this is where we'd be concerned about compromising our user data and allowing any kind of sensitive information to be stolen from our user. Now, luckily for us, we've been dealing with network security and web security for a while, so the protocols and the plan essentially is pretty well laid out for what we should expect as far as protecting our network, but there's always new attacks that are being developed. So today what we're going to do is talk through some of these basic ideas and then some of the code that goes along with some of these basic network settings and web security settings. Now let's just start by talking about some of the components of a network. So let's say we build a large-scale application that we deploy to the internet, and let's say that application is something like ChatGPT. Now on the back end of that application, we've got a lot of different models and data that are being handled. And along with that comes many different computers, many different networks that are being brought into their internal server network, different databases, different companies that own different databases, storage and transportation of secure data for their users, assimilation of all of their data, sending an application, a front-facing user interface out to a browser, and then on top of that, any other web services that the development team may need access to actually build an application like ChatGPT. So networks can be incredibly complex, and a network could consist of hundreds, if not thousands and thousands and thousands of machines. And so ensuring the security of a network and ensuring that there are no vulnerabilities in that network is a very complex topic to deal with and a very hard task for someone to try to wrap their head around. But what you have to do is take it step by step and block by block and build that network from the ground up. Now, when we're talking about a single computer network, things get quite a bit simpler. So let's say we have a single server that's hosting our application and our website. And with that server, we essentially can put in an immediate fail stop, and that is our firewall. So we can set up a firewall that can direct and control the traffic that meets our server from the outside. So basically we have users that are on a browser, and from that browser they connect or try to make a connection to our server. When they try to make that connection, it first passes through a firewall, which determines if the data that is being transmitted is safe or secure or malicious. And if it is, it gets denied from accessing the server. So think about this, but times a million users, and it gets really complicated very quickly. Now, on top of that, we also have tiered network components, and this would be something similar to a large application like ChatGPT, where you're going to have entire servers that are dedicated just to hosting the application and to hosting the users and saving those users' data, and that will be protected by our firewall when the user comes in from their browser. Now, beyond the application tier, you're going to have another firewall that's going to protect the application tier from the background tier or from the back-end development tier, where you may be hosting your back-end development server or like your playground server. You're hosting models here, you're hosting data pipelines here, you're hosting hypervisors for virtual machines here, you're connecting to databases. So the tiered network is the more realistic application of these large-scale distributed networks. So when we're talking about network security, we're talking about securing this entire network from the database all the way up to the front-facing browser that a user is going to come in from. And so in many cases, this can happen through firewalling, but we also have other protocols like SSLs, which are secure socket layers, or SSHs, which are secure shells. And the difference there is that SSH, the shell, is basically focused on covering the data that is being transmitted to create a website and secure that connection to the website, whereas an SSL, a secure socket layer, is primarily going to be focused on transmission or transferring data between connections on a network. So they're very, very similar protocols with similar encryptions and decryption algorithms, but with slightly different purposes. Now, some of the most important aspects or attacks that we need to guard against are malware attacks, phishing attacks, DDoS attacks, which are distributed denial of service attacks, cross-site scripting, and SQL injections. And most of these attacks have been around for a very long time, but the reason that we're still talking about them is because these are more so broad categories of types of attacks. So depending on how you build your website, you may have built-in vulnerabilities that fall into one of these broad categories. So for instance, malware is typically a malicious piece of software. It's a very broad definition. And this malicious piece of software basically allows someone to gain unauthorized access to your network or to your web applications. And we can typically prevent these kind of attacks by implementing an antivirus or anti-malware software that basically regularly is scanning the entire network and installing software updates when necessary, restricting users from downloading bad or potentially malicious pieces of software, and then also regularly checking for any kind of software that may have an attack going on it. So a piece of software that's potentially compromised. Now, phishing attacks are more so about getting personal sensitive information out of a user. So this is the very common attack right now that occurs across email or even through your phone. If you get random text messages that you don't know where they come from, that's likely a phishing attack. And so this is where a hacker or some kind of adversary is looking to collect login credentials, financial data, and sensitive information. And unfortunately, it's kind of hard to protect against a phishing attack. The easiest way for you to ensure your safety against phishing attacks is to educate your users. If the people are aware that phishing attacks may be coming into the network, you have a higher chance of them flagging them as junk mail and then sending them to IT, and IT restricting any kind of emails coming from that URL again. Another way we can guard against phishing attacks is by using multi-factor authentication with like OAuth 2, or just straight up encrypting our data and using something like the ECDSA algorithm to create secure connections. Now, DDoS or distributed denial of service attacks are basically when someone is trying to overwhelm your website or network with traffic. In this kind of attack, the goal is just to shut you down and try to get into your system. Really, the only guard against a DDoS attack is to implement a firewall, have detection and prevention systems, and then to regularly check your network to ensure that your network is still safe. Otherwise, once the attack has occurred, you really don't have an option besides to take the site down, wait for them to stop attacking, and then find the flaw in your code and repair it. Now, cross-site scripting is when we have malicious code that's brought into our website or application from an outside website or application, and then a user that is using your application actually executes the attack. And it's more than likely that they don't know they're executing an attack. This is a type of software that basically is picked up on accident. It's kind of like a sucker fish. You pass by it while you're interacting with the website, it sticks to your data and to your browser. Once it gets to the website of interest, because it knows that you're going to go there, and you execute that code, then that site is now being attacked. And there are some common coding practices that can prevent this kind of attack, such as input validation or implementing some kind of security framework in Flask or Django, and we'll talk about those today. And Django cross-site scripting is actually a built-in security module to ensure this doesn't happen. And then lastly, we have SQL injections. And SQL injections are similar to cross-site scripting, except the SQL injection involves injecting malicious SQL code into the web application. So this is basically sneaking in through the database rather than through the HTML or whatever other code you're using on your website. And preventing SQL injections is primarily about parameterized queries input validation, and then just implementing security frameworks such as SQL Alchemy. So that's a basic overview of network security and web security. So let's go into some more specific examples. So for network security and Python specifically, we'll be using a package called Scapy. And Scapy is basically an interactive packet manipulation library in Python. So Scapy is able to forge and decode packets of a wide number of protocols and then send them or capture them and match requests and replies and much more when it comes to network protocols. And if you're unfamiliar with networking, a packet is basically a piece of information with all the details on where that data is supposed to be sent, and the packet is the entire concept of how computers are networked. So the packet is the original piece of data that was invented or the data structure that was developed to network computers. And so we still use packets today. With Web3 coming, I believe we'll still use packets then, built into the protocol, just in a slightly different format. Now, with network security, one of the key parts that we talked about was scanning or regularly checking your network. So we're going to discuss some of the basic ways that you can scan and identify potential targets or vulnerabilities in your network. And so the first thing that we need to do to scan a network is to download Scapy. So we're just going to do pip install Scapy. Now, when we go to scan a network, we have multiple different possibilities. We could scan a single computer or a single IP address. We could scan an entire network of IP addresses. We could scan just a hub or a section of our network of those IP addresses. So we have a lot of different options. So I'm going to show you today how to scan a single IP address as well as a whole network of IP addresses. So the first thing we're going to do, of course, is import from scapy.all, import all, or the asterisk. And then what you're going to do is name your IP address. So I said IP address is equal to, and then this is the common IP address format for homes in North America, at least 192.168.1. And then whatever your specific IP address is on your network. So we'll save your IP address as an object called IP address. And then with that IP address, we're going to create a new variable or new object that's called response. And response will be equal to SR1. This is basically saying, for this response, I want to receive a single packet of data in return. And then we're going to say ARP. ARP is referring to a specific protocol. Inside of ARP, we're going to define our IP address of interest. Then we're going to tell it how long to wait for a response before it times out. This could be anywhere from 0 to 1,000. In our case, I did 5. And then verbose will be set to 0. This is basically saying we are not expecting a specific output, or we're not expecting a printout of this response data. After we've defined our response, we're going to say if response is not none. So if there is some kind of data in that response, then what I want you to do is print the IP address of that response, as well as the data, and also the MAC address of that response. If not, I want you to print no response received for that specific IP address. And just like that, in 5 lines of code, you can quickly scan your single IP address and figure out if there's any devices on your network that you should be concerned about. So this allows you to perform a quick vulnerability test on one single computer or one single address within your network. Now, if you need to scan an entire network, we need to have the correct network address. So if you're unfamiliar with the concept of networking, there's something called a subnet mask. And basically the subnet mask is kind of an umbrella. Think of it as an umbrella for your entire network. And the subnet mask determines the range of the IP addresses on your network. So the subnet kind of says, okay, this is our setting for the entire network. And then within this setting, you can have these possible IP addresses that fall under this umbrella. So, for example, if your IP address in the US is 192.168.1.1 and your subnet mask is set to 255.255.255.0, you have the possible range of IP addresses from 192.168.1.0 to 192.168.1.255. So to scan your entire network, you need to check all the way from 0.1.0 to 0.1.25. So in order to do that within Scapy, what you can do is set up basically this kind of slash protocol or a way of indexing based on that IP address. So we can set the IP address for the entire network equal to 192.168.1.0/24. And so by using this notation, we can check the entire umbrella that falls into our network. Now, to turn this into code, we have, again, a very short section of code here. What we're going to do is import from Scapy, and then we're going to set our network, and our network here, again, is equal to 192.168.10/24, and that gives us access to the entire subnet mask. Once we've defined our network, similarly, we are going to set up a response variable, that new object. So in this response variable, we're asking for SRP. SRP is basically a way of creating a raw socket that's customized to our needs, and in this case we're going to request multiple return packets. Within that SRP we have the ether, which is Ethernet, so we're defining an Ethernet layer connection based in this format, and then on top of that we are asking for ARP. And again, that ARP is basically our request layer on the network. So this is telling the network which piece we're trying to connect with. And then we tell it that the addresses we're interested in are equal to the variable network, which we defined up above. And then again, we tell it how long to wait before it times out. And then how much detail or how much information and what type of response to turn out based on the verbose variable. With that, we then ask for it to just give us a simple print statement, basically telling us what the IP address is for all the devices on the network and what the MAC addresses are for each of those devices. And then we say for each of those elements in the response variable, so in that return packet, for every element or every device that is in that return packet, I want you to print that element's data sequentially in a list so that we can monitor and scan that network and see if there's anything that we weren't expecting or any devices that should not be connected to the internet at that point. So this code allows us to perform what's called an ARP scan on a specific network based on the IP addresses and the MAC addresses. And this ARP scan is a standard in the networking world. Now, besides scanning our network, another form of scanning or analyzing our network traffic is packet sniffing. So this is basically a way of determining if an attack is occurring in real time. So this is our way of detecting and trying to prevent someone from getting a piece of malicious code or malicious software into our system. And if you want to read more in depth about packet sniffing and the background of it, you can click on this link here. But a quick overview here tells us that with packet sniffing, we have two different kinds of sniffers. So the first would be an unfiltered sniffer, and then the second would be a filtered sniffer. So an unfiltered sniffer is when you put a packet analyzer in before your firewall. So we have the raw data input from the internet coming in and trying to go through our firewall network here. Now, as that data is coming in and before it reaches the firewall, we have a sniffer set in to scan all of the packets that come in from the internet and analyze every piece of data before it gets filtered. Now, the alternative there is to use filtered packet sniffers. And in this situation, basically we allow the data from the internet to come and go through our firewall and be filtered by their firewall. So technically it should be cleaned up. But on the other end of that firewall, once it's actually in our internal network, so it has access to our devices, our computers, our routers, our modems, all of the above, we have a packet sniffer on the filtered side of our network, which basically can determine at that point if any malicious code made it through the firewall, which would allow us to update the firewall to prevent that from occurring again. Now, at this point, once it's inside of your network, you also have another issue to deal with because you have malicious code that got into your network, and if it has enough time to activate and execute, well, you've got a bigger issue to solve. But this is the basics of packet sniffing. Packet sniffing is a way of analyzing the traffic of your network continuously. So, as I said, you can either have unfiltered packet sniffing where you analyze every single piece of data that crosses the network, or you can have filtered sniffing where you only analyze the things that your firewall did not catch or did not filter out. And so we're quickly going to talk through how to set up a packet sniffer. And so we're going to use a package called libcap. Libcap is a user space interface interface that basically allows you to interact with Linux kernels, and it doesn't always have to be a Linux kernel. There are also security modules in here for Unix or Unix-like systems. But the important part here is that libcap has the capabilities of partitioning and giving powerful root privileges that set distinct ways of allowing a packet sniffer or a network analyzer to access specific privilege to determine the quality and the security of the data that's crossing the network. So our first step here is to actually install lib. So we're going to say sudo apt-get install libcap. I also did libcap dev, and the specific installation packages are available here on the Debian website. Now, after we've got libcap installed, again, we're going to be using Scapy. Scapy, again, is our major Python networking package. And within Scapy, basically what we're going to do is define a function. And this function is going to be called packet callback. And so this packet callback function is capable of sniffing all of the incoming networking traffic, looking for packages that may contain sensitive information like usernames, passwords, or whatever you want to set it up to be, and then putting that information to the side and basically giving you a printout or a log of that data so that you can determine if that is an attack or if it is a secure transmission of data. So as far as defining our packet callback function here, we're going to say define packet callback, and the only parameter is the packet. And we're going to say if the packet has a TCP payload, then that will be equal to the mail packet, and we're going to convert that packet TCP payload into a string. And then we're going to say if there is a user or a password in that mail packet, then we want to print out that information based off of the server and the packet information, the packet IP destination information. So you can not only say, yes, this crossed my network, but you can also say, yes, this crossed my network, this is where it came from, this is where it's going. And you can make it even more complicated than that. And then after you print the destination of that packet, you also want to print out what the payload was. So what data were they trying to transmit? So with these 10 lines of code, maybe 15 lines of code, you can sniff all of the traffic on your network, analyze it, determine if it's safe and credible and secure, and then transmit it to its final destination. And if it's not secure, well, you can also set up functions or protocols and procedures to handle unsecure data that's trying to pass through your network. And that also gives you the information that you need to update your firewall so that you don't have to do this filtering by hand. You can add some level of automation to it. So that's basically it for networking traffic right now. We'll get more into it on our lab day, but this is where we'll end for today. Now with web security, we're specifically going to talk about cross-site scripting and also SQL injection and preventing those on our websites. So again, cross-site scripting is basically a vulnerability where an attacker can inject malicious code into the web and it's executed by an unsuspecting user. So someone is just casually viewing your page, and whether they brought the code with them from another website or whether they had planted the code on your website and that person is now activating it, both are XSS attacks. And luckily for us, these kind of attacks have been known for a long time. So libraries like Flask or our other web development library in Python, Django, have built-in security features that should be able to handle this. And so we're going to talk through those now. So the first thing we need to do is install Flask. We're just going to do pip install Flask. After we've installed Flask, we're going to install Flask SQL Alchemy and then also install SQL Alchemy. Flask again has that built-in SQL security, but we also want to install the SQL Alchemy package on its own. Now, once we've got all our required package, we're going to come in and say from Flask import Flask, render templates, and then requests, and then we're going to say from markup safe import escape. And then it's very simple to set up this cross-site scripting protection. We're going to say that we need to set up an app that's called Flask and has a specific name. We're going to route that app to just simply say hello to us, and then we can say define hello, which will be the escape of our request, basically saying say hello world and return a template that has a string that says hello world, and then we define if the name is equal to main to run the app. So this code just simply renders a template that includes a user's name, which is passed through a query parameter, and then the built-in Flask security features automatically prevent any potential escape of dangerous characters. So that's what this escape function is doing. It's basically preventing that data from leaking into the HTML code. So it's guarding that data with a built-in module. And so if you're working on a small website or a rather simple website and not a complex platform, and you're using the Flask module to develop that website, you can add high-level security to your website with this very simple amount of code. So you can add high-level security to your website with one simple function. And that is awesome. And you definitely should do this if you're building these kind of web applications. Now, the other type of web security that we need to be aware of is SQL injection protection. SQL injection basically is when someone injects the malicious SQL code into your web application, and then they can execute that code in your database. So it's a way of corrupting your database and then gaining access to the back end of your web application. Now, again, we can use the SQL Alchemy library to prevent this from happening with the Flask web development framework. So what we're going to do is import a bunch of things here. We're first going to import Flask and request to make a request to our website, and then the Flask framework. Then we're going to specifically import the SQL Alchemy module. We're going to import specific submodules in SQL Alchemy, such as column, integer, string, and create engine. The reason for this is instead of using a regular SQL database to set up the protection, we're going to go through the SQL Alchemy module, which will build and run the database for us. And then once we've built and run the database through the SQL Alchemy protection layers, we can connect it to our standard SQL database. So once we've got those imports done, again, we're going to name our app. Our app here will just be Flask name. And then we're going to create a declarative base for our app. What this declarative base function basically does is it tells SQL Alchemy what kind of tables it should be collecting. And then based off of those tables, it collects the tables and the data, ensures the security, passes it to your SQL database. So we create that base for the entire application. Now in this case, again, we're going to pretend we're working with user data. So we're going to define a class this time that's called user, and the user will take one input, which is the base. So based off of the database table that we just established as the base of our application, we're going to pass that as the input to our user class. Now within there, we need to name the table because the declarative base function is looking for a table name. In our case, we're going to name it users. And the users table will have 3 columns or 3 different parameters. The users will have an ID. That ID will be a column that has integers and will have a primary key, will be set as the primary key for the database. Then we will also have a username for each user. Again, that will be a column, and that column can have a string of up to 50 characters, and each of those usernames has to be unique according to this class. And then lastly, we have the password. The password, again, is a column with a string that has a maximum of 50 characters. So that is our user. That's the data we're expecting to collect, and we're basically telling SQL here, this is the table I need you to build right now. Now, once we've got that class defined and we've declared our table, what we're going to do is create a database. So we're going to name an object that's called our engine or our database engine, and that database engine will call on the create engine function, which is built into SQL Alchemy. SQL Alchemy, then you are going to name what kind of database you want. In our case, we're just going to play with SQLite. SQLite is built into Python as well as SQL Alchemy, so it's very easy to work with. In the real world, something you might be working with is PostgreSQL. You could also be working with MySQL. If you don't want to use SQL, there are other databases like NoSQL and then also MongoDB. Once we've got the engine established for our database, then what we're going to do is define the metadata for the database. So we're going to say, based on the base object that we created, based on that table, I want you to create a metadata class and then say create all for this specific engine. And so what that does is establishes the structure and the data format for the data that's passing from your base tables through your engine back to your session. And so once we've got the metadata established, then we can then create a session. So we're going to say that our session is equal to the session maker and that it is being bound by the engine. Once we've got the session defined, then we can call on session as a function and say that our session is now equal to the session. Now that we've got all the back-end things built, we've got our class defined, we've got our database running, we've defined how our tables are looking, what we can actually do is start to run the app. So then we're going to say at app.route, we want it to route to the login page or the login template. And then within that template, we're going to define a function that's called login. And login will consist of the username and the password. With the username and the password, we're going to ask to create a new object that is called the user, or create the user, and the user will be equal to a session dot query that user, and we're going to query that user and filter by the username and the password, and then we're going to say if that user exists in the database, please return logged in successfully. Else, if that user does not exist, please return invalid username or password. And then outside of that function, we're just going to say app.run. So again, very simple setup, very simple example, but this is creating protection within our web application for the Flask framework, for this very simple web framework, web development framework that allows us to ensure that malicious code is not attacking our network and not attacking our computers or even the computers of our customers. So while these SQL injections and these cross-site scripting attacks are common attacks that have been implemented for a very long time, again, remember that they're categories of attacks. So it's not that we have one option when trying to perform this attack. It's the fact that these are very common vulnerabilities that not everyone secures against, and so people still search for them because, as you saw, it was easy for us to protect against, but that also means that it's easy for someone to attack against. So if you don't have this in place, your website is very vulnerable. And so ensuring or adding this extra layer of security just creates that peace of mind for you as you are trying to search through and understand your network security. Now, we worked with Flask today, but typically I work with Django. And there's a couple of reasons I like to work with Django, and the primary one is the fact that Django has a lot of built-in security features. Networking security and web security is not my number one motive when I'm programming or building applications. I don't always think about it, and Django allows me not to always think about it until the final steps, until I'm getting ready to deploy something for production. And the reason for that is Django has a lot of built-in features such as cross-site request forgery protection. This basically validates and generates specific unique tokens for each user based on the submission to prevent that malicious code from being submitted for a user. Django also naturally protects against SQL injections. You still need to make sure that your site is secure, but the object relational mapping built into Django adds that layer of protection and can give you some basic peace of mind. With that, also Django has built-in clickjacking protection. And then probably the nicest benefits of Django is that there are built-in authentication and authorization modules, so you do not have to write all that code yourself. You can simply import them from a submodule. And then Django also handles secure session management. So with the built-in databases, you have cookies and sessions that can be encrypted to add additional security to your website. Now, with all this said, there are still always vulnerabilities, and especially with something like Django, where Django is open source. So everyone can see the backend code of Django. Anyone can download that and look for vulnerabilities. Yes, the Django development team should be constantly updating that code, but there's always the chance that somebody's hiding a secret vulnerability in their back pocket, or someone has found a new vulnerability from a previous update that has not been patched yet. So the bottom line here is when you are building a website that you may potentially be sending sensitive data over, or a network that you're sending sensitive data over, you need to be thinking about security. And realistically, security or building security procedures and infrastructure will not take you that long to develop. It'll probably be quicker than building the application for most websites or for most, but it's another thought. So it's another thing that you need to have in the back of your mind as part of your pipeline before you prepare to release a website. Now, that's all I had for you guys today. I hope you guys found this very insightful. Like, comment, subscribe, whatever you want to do. When you come back next time, we're going to do a lab practical exercise or application of network and web security. And with that, I hope you have a wonderful day, an even better rest of your week, and I'll see you next time.